Okay, hello everyone. We are discussing about properties of inverse Laplace transform and corresponding numericals. In our last class, we have been discussed linear property corresponding inverse Laplace transform, then change of scale property, then shifting property, then Laplace transform of derivative, Laplace transform of integration, derivative of Laplace transform, integration of Laplace transform. Up to this much we have been discussed in detail, and corresponding numericals also we have been discussed. In our today class we are going to discuss another property and corresponding inverse Laplace transform, that is your second shifting property. And we are also going to solve some numericals based on inverse Laplace transform of second shifting property. So we know that by this property, Laplace transform of f of t minus a into u t minus a, here u t minus a is your unitary step function, this one. Okay, we have been discussed in detail about unitary step function, this one. Okay, here u t minus a is your unitary step function, will be equal to e to the power s, e to the power minus sa into capital F of s, where capital F of s is nothing but your Laplace transform of f of t. Hence, that implies inverse Laplace transform of this one will be equal to this f of t minus a into u t minus a. We are going to use this one to solve the numericals. So this one is the first numerical, that find out inverse Laplace transform of e to the power minus pi s by s plus 3. Okay, so first we are going to find out inverse Laplace transform of 1 by s plus 3. So 1 by s plus 3 inverse Laplace transform will be e to the power minus 3t, because uh, if we are going to consider our 16 elementary functions, this one Laplace transform of e to the power at is nothing but 1 by sa, 1 by s minus a, and corresponding inverse Laplace transform will be e to the power at. So if it will be s plus a, so obviously it will be e to the power minus at. So if we are going to use that elementary function and corresponding inverse Laplace transform, then inverse Laplace transform of 1 by s plus 3 will be equal to e to the power minus 3t. Okay. Now the given question, inverse Laplace transform e to the power minus pi s by s plus 3 can be written as this one, e to the power minus pi s into 1 by s plus 3. Right? Here 1 by s plus 3 is to be considered as this one, capital F of s. That means if I am going to compare this one with this, then here capital F of s, here 1 by s plus 3. So here e to the power minus sa, here e to the power minus pi s. That means if I am going to compare this, then a equal to pi. So inverse Laplace transform of this one is nothing but f of t minus a, u t minus a. So here a is your how much, pi, so u t minus pi will become up. Then here this one is nothing but the so called f of t, this is so called f of t, but by applying second shifting theorem, this should be f of t minus a, as a is your pi, so this will be e to the power minus 3 t minus pi. So this will be the answer. Next question, inverse Laplace transform of e to the power minus s whole divided by s plus 1 whole cube. Okay, so inverse Laplace transform of 1 by s plus 1 to the power 3 is nothing but e to the power minus t into t square by 2 factorial by using fast shifting property. This type of numerical already we have been done. Here you can see 1 by s plus 2 to the power 5 is nothing but your e to the power minus 2t into t to the power 4 by 4 factorial. So here it is to the power 3. So obviously this will be t to the power 2 divided by 2 factorial. Here 5 t to the power 4 by 4 factorial, and here a is nothing but minus 2. So e to the power minus 2t. Likewise, here a will be minus 1, so e to the power minus t into t to the power 2 by 2 factorial will be the inverse Laplace transform of this one. Now we are going to compare this one. Question. This is the question, e to the minus s into 1 by s plus 3 to the power 3. If we are going to compare this with second shifting property, then the answer should be f of t minus a. So here this is nothing but the so-called f of t. So by using second shifting theorem, we have to compare this with this. A is nothing but 1. Here you can see, here a, here 1. A is your 1. Okay. So if it is so, f of t is nothing but this one, right? Hence the answer will be f of t minus a. F of t minus a means this is f of t. So wherever the t, we have to consider t minus 1 because a is your 1. So e to the power minus t minus 1 into here t square means t minus 1 square by 2 factorial into here u t minus a, u t minus 1. So this will be the answer. Okay. Here I written why and how this inverse Laplace transform of this one will be this one by fast shifting property, that is inverse Laplace transform. If we are going to consider 1 by s cube, this will be t square by 2 factorial, and according to fast shifting property, e to the power at f of t will be equal to f of s minus a. So here t if we are going to consider s plus 1 whole cube, the s plus 1 whole cube, that means s minus of minus 1 whole cube. So if f of s minus a will be like this, then the answer will be e to the power at into f of t. So here f of t is your t square by 2 factorial, and e to the power at means e to the power minus t. Okay, here a will be minus 1 because if we are going to go 1 by s cube, 1 by s plus 1 whole cube, that means 1 by s cube, 1 by s plus 1 whole cube, that means 1 by s minus of minus 1 whole cube. So only 1 by s cube inverse Laplace transform will be t square by 2 factorial. But if this one we are going to consider, then e to the power 80 and this one e to the 80 means here a is minus 1, so e to the minus t into t square by 2 factorial. These things we discussed in detail. Okay, so here I written the cause, may you can write in your note. Okay, now we are going to go for the next question, that is your inverse Laplace transform of e to the power minus s minus 3 e to the minus 3s by a square. So we know that Laplace transform of t 1 factorial by s to the power 2 or 1 by s to the power 2, or we can say inverse Laplace transform of 1 by a square is nothing but t, right? So here you can see 1 by a square. See, this given question can be written in this way, that e to the power minus s by a square minus 3 into e to the minus 3s by a square. So if we are going to consider first term, this one, here fs is nothing but 1 by a square. Okay, and e to the power minus as, here a is your 1. Okay, now comparing with second shifting property, e to the minus s a f of s f of t minus a into u t minus a, then what will be the answer of this one? The answer will be, if 1 by a square is your capital F of s, then right hand side will be how much? F of t minus a. Corresponding inverse Laplace transform is your t. So t minus 1 because a is your 1. T minus 1 into u of t minus 1. Okay. Second term, 3 is constant taken outside. 1 by s square e to the minus 3s. So here a is your 3. So answer will be minus 3. 3 is already there. T minus 3 into u of t minus 3. This is the answer of this question. Okay. Now next class we are going to discuss about inverse Laplace transform by convolution. Thank you so much for watching this video. Thank you.